Properties of exponents. This is a review of Algebra 1, but it's going to be extended a little bit for Algebra 2. Properties of exponents. X to the m times x to the n. Notice that these are the same item. If you have two variables that are the same, two bases that are the same, you add the exponents to come up with the answer. So for example, x to the second times x to the third is x to the fifth. If I had x to the negative 1 times x to the fourth, that's x to the third. You add exponents when you're multiplying items that are like. What would x to the negative 2 times x to the fifth be? Collins. X to the third is right. And what would x to the fourth times x to the third be? Anybody else? Yeah, what else? X to the 4 plus 3? 7th, yes. And x to the 12th times x to the negative third. Anybody else? 12 plus a negative 3. Karshner, 9, yeah. X to the 9th, that's right. What would x to the negative 5th times x squared be? Yeah. X to the negative 3rd, right. And what would x to the 6th times x to the negative 10th be? Salisbury. X to the negative 4th, right. And what about x squared times x to the negative 7? Chavaria. Yep, x to the negative 5th is right. When you're dividing like terms, such as x to the m over x to the n, no matter what the numbers are, no matter what the exponents are, it's going to be x to the m minus n. You subtract the bottom one from the top. So for example, if I had x to the 4th over x to the 3rd, 4 minus 3 would be x to the negative 1. If I had, need a little bit more room, if I had x to the negative 2 over x to the negative 3, that's x to the negative 2 minus negative 3. Of course, you would simplify that just to get x to the first, which is just x. No matter what they are, no matter what the signs are, you still subtract top minus bottom. What if I had x to the 6th over x to the negative 2? That's x to the 6th minus negative 2, which is x to the 8th. Somebody give me the answer for this one. X to the 6th over x to the 3rd. What would that be? Yeah. X to the 3rd is right. What about x to the 7th over x to the 2nd? Chavaria. X to the 5th is right. X to the 3rd over x to the negative 2nd. What would this one be? Karshner.
X to the 5th.
X to the 5th is right. What about x to the 4th over x to the negative 3rd? What else?
X to the 7th.
X to the 7th, yes. X to the negative 6th over x to the negative 3rd. What would this one be? Yeah. X to the negative 3rd is right. You would do negative 6 minus a negative 3. What about the bottom one, x to the negative 4th over x to the negative 5th? Karshner.
X.
It would just be x, that's right, because you have negative 4 minus a negative 5. And those change to plus, so negative 4 plus 5 is 1, x to the first. You have x over y. This is a fraction, and it's the quantity squared of that fraction. Anytime you have an exponent outside of parentheses acting on a fraction, you distribute that exponent to each of those items, top and bottom. So you would really end up with x squared over y squared. So if I had a over b, quantity squared of a over b, I would end up with a squared over b squared. Just the same if I had x squared over y to the third, and I'm going to have all of that to the third power. The third power of x squared over y to the third. I would still distribute this 3 to each of those items in there. It's 3 times 2, so that would be x to the 6th. And on the bottom, y to the 9th. You multiply this exponent by this one and by this one. Can someone tell me what the answer to this one would be? X to the 8th over y to the 12th. That's right. What would the answer to this one be? Somebody else. Yeah. That's right. X to the negative 6th over y to the positive 18 power. You just distribute this 3 to this and to this. What about this one? What would the answer be to this problem? Yeah.
X to the 8th over y to the 6th.
That's an X on the bottom.
Or x to the 6th.
Right. He's right. And for another point, can somebody else tell me what the simplified version of that answer would be? Yeah. X to the 2nd, because you have two x's, one over top each other. And what operation do you do with the exponents? X to the 8th over x to the 6th. What operation do we do with those exponents to get x to the 2nd? Subtract. Yes, we subtract. What's the answer to this one? And you can just give me the first step if you want to. X to the negative 6th over x to the negative 15th. Yes, we will go with that. Now, once we do that, can somebody tell me what the simplified answer would be? Salisbury. X to the 9th is right. Negative 6 minus a negative 15 would be a positive 9. Anything to the 0 power is 1. X to the 0 power is 1. If I had negative 1.325 to the 0 power, the answer is still 1. If I had the third root of x to the 2nd, and that entire quantity was to the 0 power, the answer is still 1. So what would the answer be to this one? 1, yeah. The answer to this one, 1. If I had x to the negative m power, that's the same as 1 over x to the m. The negative exponent must be taken away. And the way you do that is by moving whatever it's on to the bottom of a fraction and changing the exponent to positive. So for example, if I had 3 to the negative 2 power, that's the same thing as 1 over 3 squared, which is 1 over 9. If I had something like x to the negative 3, that's the same as 1 over x to the third. So in the future, when you get answers that simplify down to something like 6 to the negative 2, you're not going to turn in 6 to the negative 2. It would be 1 over 36. 1 over 6 squared, 6 squared is 36. If I had x to the negative 2, y to the positive 4, the y has a positive exponent, so you can't do anything with that, but that x squared, that's an x to the negative 2. So you would put it as an x squared on the bottom, but that y to the 4th would stay to the top. Whatever has a negative exponent goes to the bottom and the exponent becomes positive. What would the answer be to this problem? Somebody raise their hand and tell me clearly what the answer would be if you're going to answer it. Yeah, Porter. X to the second would be on the bottom. This is y to the negative third, and we'll give her the point for that. But that leads into another one. This is a negative exponent. What happens when it was a negative exponent on the top? Where did it go? The bottom, and became positive. So what do you think happens when it's negative on the bottom? It goes to the top and becomes y to the third. So if you have both of them negative, top and bottom, then you just switch the places and make it positive. Somebody simplify this problem for me. You don't even have to do it all the way through. If there's still more simplifying to do, I'll give you the point and we'll let somebody else simplify it. What would I have to start with on this one?
You have to move the x to the negative 2 and the y to negative 1.
Salisbury had her hand up. All right, what should it be?
Flip them the x to the third and y to the second top, and then x to the bottom and y.
That's right. And if it's to the negative 1, you don't have to write positive 1 as the exponent. She is right. Can this be simplified any further? Yes. Can somebody tell me how to simplify this further? We have an x to the third over an x to the second. Lujan. Subtract the exponents, right. So what would I be left with? Yeah. I would have an x and y. That's right, because 3 minus 2 is 1. That's a positive 1, so x to the first on top. And then 2 minus 1 is 1. That's a positive 1 on top, x to the first power. Anytime you get a fraction for an exponent, if you have a fraction for an exponent, remember that the bottom number is the root that's being taken of this base. So you can rewrite that fractional exponent as radical sign, put the root on the little ledge there, and then this is raising this base to this power. So if I had 16 to the 2/3 power, that's the same thing as the third root of 16 squared. If I had 4 to the 4/3 power, that's the same thing as the third root of 4 to the 4th power. This goes here, and this is raising that base. If I had something like 16 to the 1/2 power, that's the second root of 16 to the first. And some of these problems you can simplify, especially this one. The second root is a square root. 16 to the first power is just 16. And anytime you have a square root, you don't have to write the 2 in this spot. So what is the final answer of the square root of 16? Just 4. So take it as far as you can when possible. Simplify completely. M to the 5th times m to the negative 4th is simply m to the 5 plus a negative 4, which is m to the first power, but you do not write the 1. It's just m. The 5th power of x to the 3rd. Whenever you have exponents separated by a parenthesis, you're going to multiply those exponents. So you should get x to the 15. Simplify this one completely. That's going to be x to the negative 6th, but since it's a negative exponent, you got to move it to the bottom, change it to positive, so 1 over x to the 6th. Well, you have w to the negative 4th over w to the negative 2. So that's w to the negative 4th minus negative 2. If you simplify that, it's w to the negative 2 power. And of course, w to the negative 2 power is 1 over w squared. You have this w to the negative 6th on the bottom. So that means you can move it to the top and change it to a positive 6. But now you have 2w squared times w to the 6th. So w squared times w to the 6th is w to the 8th. 2w to the 8th. If you distribute this negative 3 exponent to each of these items in here, including the 4, you would have 4 to the negative 3rd times x to the positive 6th over x to the negative 9th on the bottom. If you rearrange your negative exponents there, starting with this one, that would put 4 to the 3rd on the bottom. Of course, x to the 6th is positive on the top, but this x to the negative 9th can go to the top and become positive. So x to the 6th, x to the 9th is x to the 15th, and 4 to the 3rd on the bottom is just 64. And beyond that, there's nothing more that you can do.